Our next presenter, Mr. Marion Baggio, is going to speak to you regarding long-lasting bridge deck waterproofing. Mr. Baggio is the CEO of Alchemco, a global leading industry and manufacturer of concrete and masonry waterproofing systems.
So thank you very much for joining us today. Before I talk about bridge preservation, I'm just going to talk a little bit again about the ITD, the Innovative Technology Demonstration Work Group. Currently, we are about 20 members. If you are an agency and you would like to learn more about it, you can talk with Kyle and myself. We are on the exhibitor hall as well. And currently, there are 8 innovations that we study, and we have different programs. When we talk about innovation, it's always very hard to do it for multiple reasons. One of them is people don't have time to talk about innovation. They always have something else to do. And all the products that currently are on the ITD program, usually there's not a lot for them. So we're talking about a technology that when I talk with a DOT engineer, they ask me, all right, is this similar to this technology? And the answer is no. All right, is this similar to the other technology? And the answer is no. So we try to explain that, it flies, but it's not a bird. It swims, but it's not a fish. And everybody has a hard time understanding because it doesn't fit a specific slot. So many of the technology that we have on the ITD, it's always about that. It's a technology that there's not a lot of technology similar to that one. They bring a lot of value to the industry, but we do need the opportunity to show this type of technology to the market. When we talk about, this is also about innovation. And what's interesting about here, what we can see, is that this is the increasing of production. And it's very sad to see that construction is way on the bottom. So what we are seeing here is that the average increase of production from the 90s until 2018 was about 60%. Some industries like electronics and manufacturing increased 200%. And some industries like construction, it's not very good for us, as we can see here. So this is very concerning. And the reason why this is very concerning, and they did a study to try to understand why that was happening. And you guys are never going to believe why that happens. It happens that construction has lower margins. This stuff of DOTs closing with the lowest bidder make everybody work with lower prices. And if you have lower prices, you don't have margin to invest in innovation. So no one is investing in innovation because there's no margin on the construction industry to try something new. And that's not the reality for other industries, as we can see here, the agriculture or the manufacturing. So the construction industry loses a big opportunity to increase production, and it's very sad to see that the production is going down after 30 years just because the margins are so low that there's not room for innovation. And it seems that I'm talking against innovation, but actually it's the other way around. I'm talking in favor of innovation. Here, so these ones is from the United States, and this one is global. So even both scenarios, they're not good. So construction is also not good, this one being international. And yesterday I mentioned about 2 types of innovation. I mentioned about incremental innovation. So there's a first product that's a low quality product. Then there's a second product that's a medium quality, and then the product gets better. And we also mentioned yesterday about disruptive innovation. So there's innovation that in the beginning is completely different from the way we used to do business before, but now we got used to this new innovation. So let me give you some examples. We had metal, wood, and glass, and then we create plastic. And plastic, there are way more utilities to do with plastic than we had before. And then, as you can see here, we have chemical photography with digital photography, landlines, and this I think was the example that I mentioned yesterday, with mobile phones, and CD or DVD with streaming. So when we talk about innovation, this is usually what we see. Here we have, it's very interesting that the digital transformation, the numbers that I'm going to give here, either they are how much the industry is or how much we're saving. So the digital transformation is 100 trillion, the e-commerce is 22 trillion, the artificial intelligence over $15 trillion, climate change mitigation, $7 trillion, and a forever lasting concrete is $1 quadrillion. Again, I'm not American, I'm not sure if quadrillion dollars exist, but I just thought it was an easy, funny thing to say. And when I was doing the presentation, I typed 1 quadrillion. It reminded me, Austin Powers say $1 million. So I just thought it was, funny. Regardless, even though the forever lasting concrete, it might not be a $1 quadrillion. However, concrete is the most used material in the world. So that being said, if we're able to make concrete last longer, we are saving taxpayers' money, we're making the structure last longer, and we can use our budget to build new structures. So that being said, let me start my presentation. Alchemco produces waterproofing materials, spray applied waterproofing products. One of our materials won the most innovative product awards in 2020, so just a couple of years ago. We are a global company. We have projects in 75 countries for the last 45 years. A few years ago, in 2018, we bought a company from North Dakota, TechCrete LLC. That was the company that created, back in the 70s, these technology that we are presenting, that we're going to be presenting today. We have different type of projects, from bridges to airports to commercial buildings, airports, all over the globe. So as you probably seen, from water parks to aquariums to monuments. So we have really a lot of different projects. This is the technology that we are part of the ITD, this gel technology. And I showed you guys yesterday the gel formation. I have the video here for those who were not here yesterday. But this technology is a gel. It's a liquid that penetrates in the concrete about 1/2 to 3/4 of an inch and forms a flexible barrier inside the concrete. So a lot of the issues that we face with other technologies that they sit on top of the concrete, that doesn't happen with this technology. And being flexible, being a gel, it handles thermal stress very well. So this is a video of the chemical reaction. If you guys want to see that live, we have some material in our booth so we can show you guys the chemical reaction. But we use a clear cup to show the reaction that's going to happen inside the concrete. So as you can see, immediately when one product is in contact with the other, it forms this white gel. And this white gel is exactly what's going to seal the pores, cracks, and capillaries of the concrete. And often when we talk with DOTs, they have a bunch of different questions, as our technology is not a silane, is not an epoxy overlay, is not a methacrylate. So it's a technology that they don't know where this technology fits. So here are a few of the questions that we often hear from DOT engineers. First question, and I realize that this is probably the major concern of a DOT, is how long do I have to close a bridge? So it's a very short application period. The lane is often open in hours, so 4 to 6 hours. So it's a very short lane closure. The life expectancy, so how often do I have to go back to that bridge to reapply the material? So our materials, they last a long time. Depending on the product, they last up to 25 years. And we have another technology that lasts even longer. The other question is if it's a flexible or rigid product. So this product forms a flexible gel. The majority of the projects that we do outside bridges, they are parking structures, rooftops, areas where you have thermal stress. And if you do have thermal stress, you need to use a flexible waterproofing, otherwise it's not going to handle the thermal stress. The other question is about the viscosity, so how thin the product is. This product penetrates cracks, micro cracks, so it's a very fluid material, and it's going to be able to penetrate very well on the concrete. Prep is another major concern. It's a very easy preparation, often just pressure wash the structure, and that's going to be clean enough to receive this penetrating waterproofing material. The application temperature is 40 degrees and rising, so we cannot apply on freezing temperatures. And this might be a concern for a few territories, depending on when we are applying. It's a low-cost material, and yesterday we were talking also about the life cycle cost. So not only the material is a low-price product when we compare with other technologies, but the life cycle cost is very low. When you understand that often when we're discussing the cost of this system, the number one item is lane closure. So lane closure is the single most expensive item on a bridge on the application of a product like ours. So if they are able to do that every 25 years, becomes a very low life cycle cost. And here are some benefits and interesting points about this technology. Not only this material has the ability to seal 2 millimeter cracks, and 2 millimeters is the width of a car key. So if you see a crack on the concrete that you can put your car key inside, this material would be able to waterproof that crack, so water will no longer penetrate. And also the material remains reactive inside the structure. So every time when I have water, for example, water from rain, water is going to reactivate the material and give this material the ability to seal future cracks. So cracks that happen after the application. And we know that concrete is going to crack. So that's the sustainability part of the material, that the material keeps improving with time. We have projects, as I mentioned in the beginning, in 4 continents, in Asia, Europe, South America, in the United States. So we have from very cold environments like Ukraine and Russia, and to very warm environments like Florida, Italy, South America. So we probably have applied the material on a temperature similar to the temperature on your states. It's easy and fast to apply, so you don't have to close your lane for a long time. It's a long reapplication period, and it cannot be damaged. So as all the reaction happens inside the concrete, it really doesn't matter what happens on the surface. So if you have plow trucks, whatever it is, it's not going to damage the material because there's 3/4 of an inch where the material is inside, forming this flexible gel. We have some side effects of the material, as it's going to densify the concrete, it's going to make concrete harder, which is good news. It's a green material, so there are no VOCs. We have the potability certificate, the NSF 61. And the reason why we have this potability certificate is because a lot of times our product is used to waterproof pools and water tanks, so where you have potable water. And the reason why I'm mentioning that is this is a good example to try to understand that this is a waterproofing product. It's not a sealer, it's not an aspire, it's not a water repellent, it's a waterproofing product. Here I have an interesting video. You can see this is a parking structure in Tennessee where you probably can see a lot of different cracks. Let's see. Laser pointer. So you can see here the cracks, and we saw the metal plate in the beginning. Now, and there's probably 1 or 2 inches of water on top of that. Now we're going to see the underside. We are able to see on the underside that we have water leaking. So we know that there's water on top. But what's very interesting is that all the cracks that they were leaking before, now they're completely dry. And that's exactly what I'm talking about, the capability of this technology to seal existing and future cracks in the concrete. So we see all cracks and they are completely dry. So this is a great way to see the product performance with time. So if water is not penetrating the concrete, you already know that you're not going to have corrosion. In order to have corrosion, we need water. So the de-icing agent that we use, the salts, all of that's going to damage the structure, that's no longer going to happen because water is not part of that reaction. This is an interesting test that was done back in the 80s. It's a parking structure where this product was applied in 1988. So it was a leaking parking structure. They had a bunch of cracks. And after the material was applied, they did the first test in 1993, so 5 years later. And they were able to verify that the area was completely dry. And then they did a new test 29 years later, so in 2017. And so 29 years after the original application, the area was still watertight, and the cracks that were leaking back in the 80s, now they were still dry. So nothing was done. We had a testimony from the owner of this parking structure. So nothing was done, and the area was still watertight. So when we talk about the longevity of this technology and a DOT not having to go back to a bridge to reapply something that you probably would have to reapply every 3 or 5 years, this brings a lot of value to DOTs. We have 3 different products with the same base technology, and the main difference between them is the crack sealing ability and also the durability of the product, the reapplication period. So if you have a bridge that's in a good shape, you don't use a lot of de-icing agents in your territory, and there are not a lot of cracks, you can go to a product, one of them, that it's a 15-year reapplication period and is able to seal a 1 millimeter crack. And we have up to the waterproofing product That's the bridge deck waterproofing agent. That's a 25-year reapplication period, and the product with the ability to seal 2 mm cracks. So I'm going to show some videos of the application in different states. We have different ways to apply, but usually the product is spray-applied using either a backpack sprayer or some other equipment that I'm going to show. This one here, the application rate's about 20,000 square feet per hour, so it's a pretty fast application. The product gets dry, depending on the environment, from 4 to 5 hours, or if it's a warmer day, 2 to 3 hours. And after the application, we use water. This product has enzymes, and this is one of the interesting things about the product. These enzymes, they need water to make the first reaction with the concrete. So after the application of the product, we use water to help the product to penetrate further and also to start the reaction from the product with the concrete. So here's Oklahoma DOT. They're using this equipment. It's what's interesting about this equipment is that your maintenance guys, they don't have to carry a backpack sprayer with 4 gallons of product. So they use just the sprayer, and they have the hose inside a bucket. This is in Iowa. They're using a 4-wheeler to apply the material. And again, there are different ways of applying, and in this fashion, it's about 30,000 square feet per hour. So it's still a pretty fast application. This is South Dakota. Using this spray rig and their equipment, it's about 40,000 square feet per hour. So pretty fast application as well. And as I mentioned, after the spray application, you spray water. And water is exactly what's going to start the reaction. So here's water application. Some people ask if this is product application. I wish. It's not. It's just water. This is exactly to help the material to penetrate further. These are some of the states where we have applied this material: Washington, DOT, Minnesota. This is the test, part of the ITD. As we mentioned before about the ITD program, the idea here is to test before the application, after the application, 1 year, 3 years, 5 years, 10 years. So we're able to show to the DOT that the product's still there, the product is reactive, and we are protecting from, for example, chloride ions. With the different technologies that we have with different products, with this test, we're able to show exactly the increase of performance of the structure. So we have Illinois, the spray application here, Ohio, different bridges, that's Iowa, South Dakota. And again, my goal showing different states is really to show that there are different ways of applying the product. Regardless of the equipment that you're going to use, it's going to be between 3,000 square feet per hour per person up to 40,000 square feet per hour per person. So it is a fast process that brings a lot of speed to any given bridge. And again, you don't have to go back to that bridge to waterproof. The product can be applied on vertical and horizontal. So here we have Delaware. They are applying on gersel barriers. So the material, you're able to see both sides of the application. You can see they applied on one side, then on the other side, and the material penetrates the same on horizontal or vertical. And this was a bridge here. Usually we spray on the entire structure. This case, they only flood the cracks of this bridge, the Fort Pitt Bridge, with our technology. Here we have New Jersey DOT, and this was a night application. So to summarize and to finish this presentation, when we talk about this technology, it is a different technology than silanes, siloxanes, epoxy overlay, methacrylate. So it's not the same type of technology. It's a technology that's going to last longer than many of the technologies available on the market. It's a green product. As I mentioned, we have the potability certificate. There are no VOCs, so there's no smell on the product. This material is able to seal 2 millimeter cracks, so cracks of the width of a car key. The material does not trap moisture inside the concrete. So what's interesting is that when you don't have water, this gel that I mentioned to you guys is going to shrink. When the gel shrinks is exactly when the water that's trapped inside the concrete is going to be able to evaporate. So you're going to be able to remove any water that was trapped inside the concrete. Due to the permeability of the material. It's a high resistance to chemicals and chloride ions. It's increased the hardness of the concrete from 6 to 8 on the Mohs scale, so it's going to densify the concrete as well. It's going to increase the compressive strength. The test that we have is about 40%, so from 3,500 psi to 5,000 psi. And as I mentioned of this product being a waterproofing product, we have a water pressure test of 1,300 feet of water pressure with no damage to the waterproofing and no leaking, which is really unheard of. I don't know any other technology that's able to handle such a strong hydrostatic pressure. It's a very fast application, so the land closure is very short. It's a flexible product, so it's gonna work within your structure, non-toxic, lower overall cost. It's a ready-to-use material, so there's no concerns of pot life or nothing like that. You open and you spray that to the concrete. And it can be applied on both sides, on positive side and negative side. However, we do recommend applying on the positive side every single time. In order to apply the material, the concrete should be dry. So in dry, it's 10% or less of moisture content. And the rule of thumb is 24 hours with no rain. So that's it. Right, any questions? All right, so the question is, how long can we apply the material on new concrete? So the material can be applied after 14 days. So if you're placing new concrete, 14 days later, you can apply the material. And if it's an existing structure, it really doesn't matter. We have done, I don't remember the name of the bridge, but we did a historic bridge in Maryland that was, I think, 100 years old. And all over the globe, we have done older structures. So it doesn't matter if it's old, that's not a problem for the technology. But if it's new, it should be 14 days or older.
I got a question. The question is regarding scaling from chloride. Have you seen in your tests on the parking lots or bridge decks where you've applied the product and concrete scaling for maybe some chloride has reduced or has it have an effect, positive or negative?
Sure,
with that?
thank you. When it comes to a lot of the issues that happen to the concrete and that they lead to the premature deterioration of the concrete, they happen mainly to 2 or 3 reasons. One of them being water, the second being chloride ions, and the third being the calcium, the free calcium available. So what's going to happen with this technology is as soon as this product penetrates the concrete, it's going to react with the calcium. So now we no longer have the free calcium available, and the free calcium is going to, as we don't have the free calcium, we're not going to have carbonation, and we're not going to have calcium leaching or nothing like that. The second step is the gel formation that we saw on the chemical reaction. When this gel formation happens, we block water from penetrating. So we don't have new water penetrating the concrete in the structure. So if we don't have chlorides, if we don't have the free calcium, and if we don't have water, a lot of the issues that happen, the lamination, for example, they're no longer going to happen because we are removing the ingredients that lead to this deterioration. So as we are removing that, there's these deteriorations, they're not happening. So the question is how deep the product penetrates, and it penetrates between 1/2 and 3/4 of an inch to the concrete. Yes. So the question is if there's any permits to what? Sorry.
Collect the water.
So what's going to happen is that the state by state, they have different regulations, and some states, they do request to collect the water. As I was mentioning during the presentation, we do supply this material to water tanks. In water tanks, and we have one of the certification, that's the NSF 61, that's a potable water certification. So this material can be applied on water holding vessels, concrete water holding vessels that they're going to carry potable water, so drinking water. And we have no problems at all. We have potable water tests in over 25 countries that they use our material to waterproof drinking water. So we know that there's nothing on the product that's going to damage, that's going to be harmful for us. However, some states, they have special requirements to collect the water during the application. And even before the application, during the pressure wash of the structure, they do require to do something with that water. Yes? Absolutely. So as the product penetrates in the concrete, the first reaction that's going to happen is between the material and the calcium that's available inside the concrete. That's the very first reaction that happens. And then when we spray water, that's the second step of the application, water is going to help the product to penetrate further in the concrete. So the 3/4 of an inch that we mentioned, this doesn't happen on day one. Usually this happens within a week or something like that after you have water, and water is helping the product to penetrate further. But the first reaction is exactly the reaction between the product and calcium. So we remove the free calcium, we don't remove, we react with the free calcium, so now you no longer have the free calcium available to that would lead to carbonation and calcium leaching, for example. So that's the very first reaction of our material. What reacts with the free calcium is one of the ingredients in the product is sodium silicate. And any sodium silicate is going to react with the calcium. So the ingredient of our product that reacts with the calcium is the sodium silicate. The enzymatic change on the product that makes this a modified silica gel is the enzymes that we have, and being a bio-based material is not the sodium silicate. There are hundreds of sodium silicate-based materials that they're not able to seal cracks and they're not able to handle thermal stress. However, they are going to react with calcium. So if you just need something that is going to stop carbonation, any $10 a gallon sodium silicate material, even at lower concentration like 7 to 10%, they're going to do a good job, but they're not waterproofing agents. They are just something that's going to happen with something that's going to react with the calcium. So the question is how these affect the pH of the concrete? Yeah. All right, so this material has a high pH and is going to keep a high pH of the concrete at about 11.7. So when that happens, this is one of the reasons why carbonation is not going to happen, because we keep a high pH of the structure.
Thank you very much, Mario.
Thank you.
We appreciate that. Thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.